So now we are going to understand the concept of exchange energy. So in case of lithium, we have 1s2 and 2s1, only one electron. In case of beryllium, we have 1s2, 2s2. Now this beryllium in 2s, now it has 2 electrons. So this is actually full filled. Now these electrons or these full filled electrons are actually called, they are having higher stability. Now I will explain it in case of nitrogen and oxygen. Let's see again. In case of boron, we have 1s2, 2s2 and 2p1. In case of carbon, we have 1s2, 2s2 and 2p2. So the next electron will go here. Now we will do the nitrogen. We have 1s2, 2s2 and 2p3. In case of nitrogen, we have 1s2, 2s2, 2p3. Now this 2p3, so all the px, py and pz orbitals, they are having 1 electrons. This is actually half filled configuration. So these electrons which are half filled can now actually change their position. What I will do, I will just draw it like this. So this is the crude idea which I am telling you to understand this exchange energy. Now in the 2p we have 3 electrons, right? So let's write it as 1, 2 and 3. Let's consider it as 1. This one is as 2, electron 2 and electron 3. So this can be in this order, or this can be like this, 2, 3, 1, or this 2 and 3 can exchange their positions, right? So it can be 3, 2, 1. So all these possibilities can happen. So these electrons can change their place. The thing is, these electrons are occupying the shells. That's why they can change their place. If it is a vacant shell, you should not calculate it. I mean, you should not consider it that this electron will go here in this position. Okay. So if in this case, in case of carbon, these 2 electrons can change their positions. Similarly, in case of nitrogen, all the 3 electrons can change their position. Now this gives higher exchange energy. That is called exchange energy. That electron can go from here to here, and this electron can go from here to here. So this is more in case of half filled configuration. But when we have 2p4, p1, p2, p3 and p4. Now you might say that still these 3 electrons can change their position, but actually not, because these are paired electrons. These electrons have their interactions, and though these 2 electrons can change their position, but the exchange energy actually decreases from the compared to the nitrogen. Now that exchange energy will increase again in case of neon. If you see the electronic configuration of neon, so that will be actually 2p1, 2p2, 2p3, then 2p4, 2p5 and 2p6. Now these 3 electrons which are having half spin, they can change their position, they can have exchange energy, and these 3 electrons which have down spin, they can change their position and they can have exchange energy. So this configuration, full filled configuration, is actually having 2 times of exchange energy compared to this nitrogen, right? So this is having 2 times of exchange energy. But there is another thing that we have to consider is the pairing energy. So as the electrons are paired here, so we have to subtract some term which is called pairing energy. For example, if we write exchange energy like E, so for 3 electrons we have E3 exchange energy, okay? Now here it will be E3, this 3 electrons generates E3, the upspin 3 electrons, and another E3 for the downspin 3 electrons. So let's try to understand again. Here we have 3 upspin electrons that can change their position, and that will gain this E3 term, E3 energy, stability. And these electrons, these 3 electrons which are having lower spin, they can also exchange their positions, and that will have another E3 exchange energy. Apart from this, we have some pairing energy also. That actually we have to subtract, because there are 3 pairs. When we are trying to exchange these electrons, we are breaking that pair. So if we take out these electrons, I will take the laser pointer for this. Yeah, see. So this is a pair, right? And this is another pair. This one is another pair. So these electrons are close to each other. They have some kind of interaction. They have some kind of energy going on, energy exchange going on in between them. So when I'm trying to do exchange of this downspin electron with this downspin electron, so I'm trying to change the position of these two. So that time first I'm breaking this pair, then I'm breaking this pair, and then I'm changing the position, I'm making new pairs. So to break that pair, to break those previous paired electrons, we need to give some pairing energy. So that actually decreases the stability. So now here we have three pairs. So crudely we can say 3p. So these electrons are changing, exchanging the upspin electrons. That's why we are getting stability in terms of exchange energy, E3. These electrons, downspin electrons, are also exchanging in between them. That's why we are getting another stabilizing energy term, another E3. And we are breaking these pairs. So that's why we have to apply some energy. We have to expend some energy. So that's why this 3 pairing energy we have to subtract. So now this one is the stabilizing energy that is working for this full field configuration. In the half field configuration, it was only E3. There were no pairing. We were not breaking any pair, right? But in case of full field, we have paired electrons, and to exchange the electrons into the same spin electrons, so we have to give some pairing energy to break those pairs. So actually this E3 plus E3, that is much greater than this pairing energy. So that's why even if we subtract this pairing energy, this value is still higher than this E3 value. So this E3 plus E3 minus 3p, this value is much higher than this E3 value. So that's why this full field configuration is much more stable compared to the half field configuration. Okay, got it?
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.